Okay, here is the review for our test coming up tomorrow, Chapter 6 test. It's all about moving shapes, transforming shapes, so translations, rotations, and reflections, and also angles and triangles and parallel lines. There's a little bit of all that on the test. So question number one says, describe the translation that maps ABCD to ABCD prime. And so what did we do to get from here, this guy, ABCD, to ABCD prime is the question. And it's just multiple choice. So they give you some choices. And by the way, these questions will look very similar to what you'll see on the test. There's a little bit of variation kind of in the way maybe some of the questions are asked or how they're laid out, but very, very similar. So if we go through this and you understand how to do these, you should be well prepared for the test tomorrow. So all you have to do is look at each of the choices. If I want to get from ABCD up here in the top left down to ABCD prime down in the bottom right, would it make sense to move left and up? I don't even need to count the numbers there to look at that. I know I'm not moving left and up. I know I need to move right and down. Correct? So there's really only one of them that could even possibly be the correct answer. If I want to get from A right here, whoops. Okay, if I want to get from A down to A prime, I need to move right 1, 2, 3, 4, 5, 6, and down 1, 2, 3, 4, 5. And that's exactly what it says here. Right 6, down 5. Okay? So far so good. Anybody feel like if that was like the only question on the test, you feel like you're passing? Okay. I think most of us are doing okay after one question. All right. Let's move down here. The vertices. What is a vertex? Where two lines do what? Intersect or meet. They form a point, and that point where two lines meet is a vertex. Okay, so where two lines meet, that point right there is the vertex. And vertices is the plural of vertex. So the vertices of figure KLMN are 1, 1, 4, 1, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 1, 2, 1, 2, 3, and 5, 3. 5, 3. And it would be really good if we label those and use a straight edge and all this good stuff. So I've got a straight line tool I can do this with, and you've got rulers you can draw with and all that. So if we do that and we label our points, it was K and then L and then M, and then N, right? Okay, and so draw the image of KLMN after a reflection across the x-axis. So which way is the x-axis? Up, down, or left? Down. It's going down from the shape would be the x-axis. So to draw this, all I've got to do is count, and so I count from K down 1 to the x-axis and then 1 across the x-axis. And how do I label that one? K prime. And is it going to be important to me as I'm grading these to see that you've labeled the points? Yes. I would write a note to yourself, label these suckers. Label A-L-A-B-E-L or L-E. I never can remember. Label and table are backwards. Table is T-A-B-L-E. Okay, so that's correct. So this one is K prime. And then do the same thing with all the other points. So L, you would count down to the line and then across the line 1. So L prime. N, 1, 2, 3, 1, 2, 3. N prime. And then M is 1, 2, 3, 1, 2, 3. M prime. And then draw the shape. Don't forget to connect the dots. We are not translating just dots, we are translating the shape. So get it all in there, get it labeled properly, right? Okay. Number 3. Oh, this is one, I guess, okay, I guess we might need the transparency papers. You can use those on the test. The transparencies are absolutely, if you use them on whatever problems you want to use them on. But if you, if you want to use one, you sure are welcome to. You don't have to. Draw the image of the triangle after a rotation 90 degrees counterclockwise about the origin. Be sure to label the new image properly. I should put that on all of the ones that require these transformations. So if you don't have a transparency, which I don't have one that would fit on this big screen anyway, we can just do some counting here. So C is the closest thing to the origin, so I'm going to do point C first, and it's at point 2, 3, and I just want to flip those coordinates, and so I want to go over 3 and then up 2, and C prime would be right there at negative 3, 2. And then A is at 2, that's 3, 4, 5, 6, 7. So I need to go over 7, so 3, 4, 5, 6, 7, and then up 2. That would be A prime. And then B is at 2, 3, 4, 5, 6, 7, 1, 2, 3, 4. So 4, negative 4, 7. So 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7. Okay, and so that would be the way it needs to be oriented on the screen. If you had the transparency, I think that's what most of us have relied on for that. I can't really show that on this screen. I always did those with the camera at the back when I was using those with you. So that's what it looks like. You will have to do one rotation on the test. And so using the transparency is probably the way most of you will do that, which is fine. Okay, we good? That one I feel bad I can't really show you that one on the screen the way I have it set up right now. Okay? All right, number 4. Draw the image of RSTU after a translation 2 left and 2 down, and then a reflection across the y-axis. So we did one unit where we kind of put all of the moves together. We did a unit each on translating, we did one unit on reflecting, we did one unit on rotating, and then we did one unit where it put those together. So you'll have to do a couple of them here that involve multiple steps of transformation. So the best way I think to do this is to do one step at a time. And so I want to move RSTU. First thing I need to do, and we need to do these in order, right? We need to do the translation first. So 2 units down and 2 units left and 2 units down. So I'm going to start with point R, and I'm going to go 2 left and then 2 down. Right here would be R prime. Kind of hit the screen too early. Woo. Okay. That's not what I wanted to do. I can start over. So 2 left and 2 down right there. That would be my R value, right? Well, then I'm going to do all of these points, and then I'll reflect them all. So R, and then S is going to be 1, 2 left, and then 2 down is right here. T, 2 left, and 2 down would be right there. And U, 2 left, and 2 down is right there. So now once I've got those dots, you don't really have to draw that in. You don't have, because that's not the final place we're going to leave it, right? That's not where I want my shape to be. That's just the first step. And so now what do I need to do? Now I need to make a reflection across the y-axis. And so I can reflect these points. This is point R. I went 2 left, 2 down. Now I can do 1, 2, 3 to the y-axis, 1, 2, 3 across the y-axis. And that point right there is R prime. Then do the same thing with each one of these. So 1, 2, 1, 2. This is where it gets a little bit tricky when we reflect. Those labels are backwards, right? So this was point S right here, And when I reflect it, S prime is now on this side. And then U across from it, 1, 2, 3, 4, 1, 2, 3, 2, 3, 4. U prime is going to be way over there. Okay. And then T, 1, 2, 3, 1, 2, 3. T prime is up here. So that's where the new shape needs to end up. Something like that. Make sure it is labeled properly. Okay? We good? You look like you have a question.
Oh wait, no, I don't.
You don't? Okay.
No.
All right. Consider the figures on the coordinate plane. I'm considering them. Okay. Which two figures are congruent? What does congruent mean? Somebody said it. The same. They are the same. They're the same shape. Okay. So, is there any shape on there that's just like figure B? No, figure B doesn't have any congruent figures on the screen. What about figure D? Figure D makes me think of a tooth. Well, I don't know why. Okay, figure D is not a congruent figure. So figure A and figure C are congruent figures, right? They're the same shape. Even though they're not oriented the same way on the page, they still are the same shape. Okay, so you could put, let's see, figures A and C. All right, so then describe it says the sequence of transformations. Is there only one right answer for this? There's lots of ways that you can manipulate figure A to get it onto figure C. Okay, and so when I grade tests like this, I have to, whatever you write, I have to check it and see if it works, because you might have a totally different way of doing it than I came up with or than your classmates came up with, and that's okay. I'm not looking for the one right answer. I'm looking for a right answer. All right, so as long as you can use your little transparency paper, right? So you can put the transparency paper on it, you can trace figure A, and then sequentially and neatly tell me what you did to get, don't just pick it up. I drew figure A and then I picked up my paper and I made it match figure C. That doesn't work. That doesn't tell me anything, right? You need to tell me what steps. So do we need a rotation? Do we need a translation? Do we need what? Rotation, definitely we need to rotate it, because we've got to get it turned over so that the arrows are facing the other direction and the little arrows on bottom and the big arrows on top, right? So we definitely need a rotation. How much do we need to rotate it? We need to rotate it 180 degrees. And rotating 180 degrees is kind of my favorite rotation, because I don't have to tell a direction then, right? Because counterclockwise and clockwise are the same thing when rotating 180 degrees. So I just need to say rotate 180 degrees around what? What do we always use as our center of rotation? The origin. Okay, so around or about is the way they usually say it. Around the origin. Now, does that get it right where we want it to be? Nope. If I rotate it around the origin 180 degrees, then this corner right here is going to end up right there on that corner. Okay? So now where do I need to move it to? Once I have it there, how much? One left and one down, okay? Okay, and then, so I'm gonna move this up here. We don't need to see the picture anymore so I can write better. So then translate down one, not right. I started to say right one, but what I meant was left one. Almost blew it. Okay? Now, there are other ways you could do a translation first and then rotate it. You could actually reflect across the X, then reflect across the Y, and that's the same as a 180 degrees rotation, and then you would have to translate. There's different ways of doing it. And so you just need to come up with a way of moving that figure to its new spot, okay? And the worst thing you can do there is leave it blank. Even if you say, move it left 3 times. And if you know it's not right, but I can't figure it out, I'm gonna give you partial credit for at least trying it, right? So don't leave anything blank. I can't help you when you leave stuff blank on a test. All right, figure ABCD is congruent to figure EFGH. So it's very similar to the last problem, except this time I give you some choices. It's multiple choice. Which one of these transformations will take ABCD down to EFGH? Okay, so get your little transparency out, copy ABCD, and then just do the steps that they say. If we reflect it across the X and then translate 4 down and right 1, does that get us there?
No.
Nope, that doesn't do it. Because if we reflect across the X-axis and then we go down 4 and right 1, that doesn't put us anywhere near where we need to be. A is no good. Okay, rotation 180 about the origin, and then down 1, right 2. And by the way, the trickiest thing about this one? The trickiest thing about this one is the way they number the graph. They did it on purpose. They're trying to trick you. Okay, so how do they number the graph? By 2s. And they do that on purpose. They want to see if you're paying attention, so look for that kind of stuff on the test. All right, so if I rotate it about the origin, then this point would end up here. And if I only go down 1, that moves it only half of a square. So can that put it in the right place if I only move half of a square? No, it can't put it in the right place. So B can't be right. But if I rotate it 180 degrees and move down a full square and then right a full square, does that put it where it belongs? That's the one. It is C that puts it where it belongs, okay? So look out for those things where they number the graph in a funny way, or they do something else silly like that makes life miserable on purpose. All right. Wow, we need to be familiar with the names and the relationships of the angles created by parallel lines with a transversal. Okay, so we need to, and this can be hard for me to get all of these on the screen. We might have to squeeze a little bit here. In the figure, lines A and B are parallel lines. Match the angle pairs with the name that describes the relationship. Some will be used more than once. Okay, so angles 1 and 2. What are 1 and 2? They're right next to each other. Which one of these things means right next to each other? Adjacent. They are adjacent angles, F. Okay, numbers 5 and 7, they are straight across from one another. They are vertical angles. Vertical angles are straight across from one another. And let's just pause right there for a second. We've got, remember these, this scenario here with the 2 parallel lines and the transversal make two angle sizes, right? And so you're either going to have angles that are congruent or angles that are supplementary. Those are your only 2 choices when we're dealing with this shape. Okay, so when we talk about angles 1 and 2 that are adjacent angles, are they congruent or are they supplementary? Supplementary. They make a straight line, right? Straight lines add up to 180 degrees, so angles 1 and 2 are supplementary. What about angles 5 and 7 that are vertical angles? Supplementary or congruent? Congruent. Vertical angles are always congruent. Adjacent angles are always supplementary. Okay? And so that It's just something you need to kind of think about, tuck back in there, because we're gonna answer some questions about finding angle measurements here in a minute. Okay, so angles 3 and 5, what are they? Are they interior or exterior? Interior. Are they same side or alternate? They're alternate interior angles. Okay, they're alternate sides of the transversal, they're inside the parallel lines. So alternate interior angles. 3 and 8. Same side interior. They're inside the parallel lines, they're the same side of the transversal. So same side interior would be A. Okay, so let's talk about those. 3 and 5. Are 3 and 5 congruent or supplementary? Don't trick me. Don't trick me into saying the wrong words. Supplementary add up to 180. Same, 3 and 5 are alternate interior angles. They are congruent. Alternate interior angles are always congruent. Okay? Angles 3 and 8, then same side interior, they are always supplementary. Okay, one way to think about it, I have 8 is a small angle, B is like an acute angle, 3 is a what do you call that? Where it's big, obtuse. That's the word. 3 is an obtuse angle. So if they're obviously not the same size. They can't be the same size, or they can't be congruent if they're not the same size. And so you can think of it that way. If they're not congruent, they have to be supplementary. What about 4 and 6? What are they? Alternate exterior. They are opposite sides of the transversal. They are exterior or outside the parallel lines. Okay, and then 1 and 6. Same side exterior. Okay, whoops, that's an ugly letter. I'm not good at writing down there that low on the screen. 2 and 6. It's the only one we have left that we haven't answered yet. Corresponding. So they are corresponding. Okay, the reason they're corresponding is because when you think about the position they have where the angles are created by the transversals and the parallel lines, they're in the same spot, right? So they're corresponding to one another. Are they congruent or supplementary? If they're in the same spot, they're going to be congruent, okay? I can go this way a little bit. Okay, angles 5 and 8. Adjacent. They're next to each other. Angles 1 and 3. Vertical. They're across from each other. 4 and 8. Corresponding. They're in the same spot. 7 and 8. Adjacent. They're next to each other. 3 and 7. Corresponding. They're in the same spot. 2 and 5. Same side interior. Okay, A. Are there more? Nope, that was the end. Oh, we just had enough room to get that on the page. Okay. I'm not going to give you all of these. You don't have this entire list to do on the test. I tried to give you just a bunch of them to look at on the review so that as you study tonight for the test tomorrow, you have a lot of, you can really work this out. You'll have a couple of these on the test that you need to identify, okay? All right. What are the measures of angles A and B? So we've got these two shapes here, and you will have to do some angle, finding the measurements of some angles on the test, okay? And so we need to remember that this exterior angle of a triangle is the same as the two remote interior angles added together. They're the remote interior angles because they're the ones not touching this exterior angle. They're removed from that exterior angle, right? So they need to be the same measurement as that exterior angle. So we went through a whole thing and we proved that when we went through the lesson. You don't have to prove it, you just have to know it for the test. So 42 plus 96 is 138 degrees. So angle A equals 138 degrees. Okay? So, to find angle B, if I know that these two have to add up to the exterior angle, what can I do to find angle B? Subtract it. It's just 144 minus 112. Equals 32 degrees. Okay? So there's two different scenarios that I set up for you. One where you know both are remote and you need to find the exterior. One where you know the exterior and one of the remote and you need to find that other remote interior angle. Okay? So you need to be able to do that. This one is kind of a little, you've got to take a couple of steps to get there, and it relates back to what we did back up on question 8, where you need to know those relationships between angles and parallel lines. Okay, so what type of angles are the 67 degree and the 113 degree angle? Huh? Not adjacent, because they're not made up of the same two lines. They're not same side interior angles. Our same side, what is the relationship between same side interior angles? What are they supposed to be? You only have two choices. They're either congruent or supplementary. So which are they supposed to be? Are they congruent? You know they're not congruent. They're not even close. So that can't be the one we're looking for. So what are they supposed to be? Supplementary, which means they should add up to 180 degrees. So we need to check and see if they add up to 180 degrees. Is 67 plus 113? What does that equal? 180 degrees. If it adds up to 180 degrees, that means they are supplementary. If they are supplementary, what does that tell us about our lines? They've got to be parallel. The lines have to be parallel to make supplementary angles there. If the lines aren't parallel, they can't make supplementary angles. Okay? So yes, and I can't scroll any further down the page because same side interior angles, that's angles, not angels, angles are, this is so hard to write down here, supplementary. Whew! We did it. Success. Okay. Now, that's the test, guys. I mean, the test is going to be very similar to that. I don't know how that makes you feel. I feel like we ought to be able to do okay at it. Maybe you feel differently. We'll find out tomorrow. Okay? All right.
Is that all?
That is